Today we're going to look at proportion word problems. You can solve problems that involve 2 units in multiple different ways. We're going to practice using a proportion because it's kind of a foolproof way to do it. So, like I said, we're looking at things that involve 2 units. So we're going to set up a blank proportion, we're going to identify those 2 units, and then I'm going to talk about down here how we're going to fill in those other rows, okay, or columns. So if it takes Mike 18 minutes to read 4 pages in a book, how long would it take him to read 10 pages? So first thing I like to do, I circle the numbers that are given to me. Then I'm going to look for the units in the problem. So it says if it takes Mike 18 minutes to read 4 pages, how long would it take him to read 10 pages? So the units that we are talking about in this problem is minutes and pages. I label it so that I don't make mistakes later when I'm working. Now I'm going to plug in what we know. For our initial ratio, 18 minutes and 4 pages. 18 goes with minutes, 4 goes with pages. Then the other number that's given to us in the problem, 10, is 10 pages. We put pages on the bottom, so 10 goes on the bottom, which means our unknown is on top. Now, I'm going to highlight my 2 diagonals. I look for the diagonal that has 2 numbers in it. So in this case, 18 and 10 is the diagonal with 2 numbers. So I'm going to multiply 18 times 10, which gives me 180. And then I divide by the number that's in the same diagonal as the variable. So I'm going to divide by 4. So 180 divided by 4 is going to give us 45. And what we were solving for, x is on top, which is with minutes, so it's 45 minutes. You should be making sure to include units in your answers. All right, number 2, there are 139.2 ounces in 16 steaks. Find the unit rate per steak. So again, I've circled the numbers that are in the problem. Now I'm going to look for the units. So it's 139 ounces, 16 steaks. So the 2 units that we are comparing are ounces and steaks, okay? You can abbreviate, you can write out the whole thing, whatever works and makes sense. Now, as I'm filling this in, 139.2 goes with the ounces, 16 goes with the steaks. Here's the difference. On the first problem, we had 3 numbers given to us. Here we only have 2. There's kind of a mystery secret number for us. When it says find the unit rate per steak, that means per 1 steak. So the other number, even though it's not there, is 1. And 1 is referring to steak. We put steak on the bottom, so our 1 goes on the bottom, our x goes on top. Again, I'm going to highlight my diagonals. And then we're going to solve. The diagonal that has 2 numbers in it is this one right here, so I'm going to multiply 139.2 times 1, which is 139.2. And we divide by the number that's in the same diagonal as the variable. So I'm going to divide 139.2 divided by 16 is 8.7. Our x was on top, which stands for ounces. So it's talking about 8.7 ounces, or you could say 8.7 ounces per steak. Okay, number 3, the Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? I'm going to set up my own blank proportion this time because we didn't put it there for you. Looking at my numbers, the units that it gives us is miles and gallons. So I'm going to label, maybe you just do M and G for miles and gallons. I'm going to write MI for miles. I'm going to write GAL for gallons. And then I'm going to plug in my numbers. 105 goes with miles, 4 goes with gallons. Then the other number that's given to us, 6 gallons. Gallons went on the bottom. I'm going to put 6 on the bottom. X goes on top. Highlighting my diagonals, and we solve. The diagonal that has 2 numbers in it is 105 times 6. When we multiply 105 times 6, we get 630. We divide by the number in the same diagonal as the variable, so I'm going to divide by 4. When I divide 630 by 4, we get 157.5, and on top is miles. Okay. One thing I quickly want to show before we flip over to the back is, and you don't have to write this part, just need to listen. The nice thing about a proportion is if you flipped it around, so if I accidentally put gallons on top and miles on the bottom, okay, I had 4 gallons, I had 105 miles, 6 gallons, this time gallons was on top, so the 6 goes on the top, X is on the bottom. We still have 105 and 6 being multiplied, and we're still divided by 4. We get the same answer. So the nice thing about a proportion is order does not matter, because sometimes people want to do the unit rate problems without proportion, just dividing. You can do that. You just have to be very careful of what goes on top versus what goes on the bottom. Okay, number 4, Ashley bought 6 books for $32.16. So I'm circling my numbers. I'm going to set up a blank proportion, looking at my units, 6 books, and it doesn't say something, but it has money, so that's our other unit. So we're talking about books and money. Plugging in our numbers, 6 goes with books, 32.16 goes with the money. Now, one thing I want to say, a lot of times with unit price, people want to go straight into dividing. Like I said, that can work, but with this specific problem is people will often, and I'm going to write this on the side, you don't need to write this, people will often just do 6 divided by 32.16 because that's the order that it was given to you in the problem. If you actually calculated that, you would get about 19 cents. So that'd be saying the price for 1 book is 19 cents, but 6 books cost $32. That doesn't make sense. So at least if you're going to do stuff like that, please make sure that you are thinking critically about your answers. Again, we don't have another number. We kind of have the mystery number. When it says unit price, we want to know how much per unit, not per dollar. So the unit that we're talking about is books. So per 1 book, we want to know how much it costs. Find the price. Now we look at our diagonals. The diagonal that has 2 numbers in it is the 32.16 and 1. So I'm multiplying those. Divide by the number in the same diagonal as the variable. And when I divide 32.16 by 6, we get $5.36. That makes much more sense. And remember, if you got like 5.3, that's not how we write money. You might have to add in zeros possibly, depending on the answer. Number 5, Sydney read 50 pages in 40 minutes. Find the unit rate per minute. Setting up my blank proportion, looking at my units. We've got pages and we've got minutes. So pages, minutes. 50 goes with pages. 40 goes with minutes. We don't have another number. It's kind of a mystery number. It says per minute, which means per 1 minute. We put minutes on the bottom, so we're solving for the top. I'm going to look at my diagonals. And we're going to solve. The diagonal with 2 numbers is this yellow diagonal here. I'm going to do 50 times 1 is 50. We divide by the number on the same diagonal as the variable, so divide it by 40. And when we divide 50 divided by 40, we get 1.25. Our X was on top, which is talking about pages. 1.25 pages per minute. Okay, these next 2 problems that we are going to do are the ones that people mess up the most. So If you want to put a star next to it so you look carefully at it, please do so. It says, Diane took a math test last week. The ratio of the number of problems Diane got incorrect to the number of problems she got correct was 2 to 7. So I'm going to note that the 2 is talking about incorrect, the 7 is talking about correct. If the test had 36 questions on it, that's talking about the total. How many problems did she get correct? Okay, so our ratio here is telling us incorrect to correct, but the number is telling us the total. So it's giving us 3 different things, but we can only have 2 to compare. So I'm going to look at this last sentence. We have the total and we have correct. So what I'm actually going to be comparing is the ones correct to the total in my blank proportion. But that's not what this ratio is. So the 2 is for the incorrect, 7 is for the correct. So I'm going to put 7 for correct. For the total, it's the total of these 2. So 2 plus 7 gives you 9. So if you had 2 incorrect and 7 correct, that's a total of 9 questions. So our ratio of correct to total is 7 to 9. The 36 is talking about the actual total. So we're solving for the actual. So this was like our initial ratio, and this is the actual. Now we can solve. Looking at my 2 diagonals, the diagonal that has 2 numbers in it is the 7 and the 36. So we're going to multiply 7 times 36 to get 252. I divide by the number in the same diagonal as the variable, divide that by 9, and we get 28. And specifically, 28 correct. All right, let's try one more like that. Madeline had a class ratio of 5 to 4 boys to girls. So our ratio is boys to girls in her classroom. There were 27 kids in her class, so that's the total amount of kids. How many girls? So we are comparing girls to total in our ratio. So that initial ratio, we're using this, but we aren't doing 5 to 4. The 4 is representing girls. Our total is going to be 5 plus 4, which is 9. Because there was 4 girls, 5 boys, which is 9 total. And the 27 is talking about the total class, so we are solving for the girls. This one you might be able to look at and just do the math without actually looking at the diagonals. And if you see that, that's awesome. Just kind of show it, because you might just see, oh, 9 times 3 is 27, so 4 times 3 is 12. Or you can do it the same way and do 4 times 27. 4 times 27 gives us 108. Divide that by 9, and again, you get 12 girls. And that's it.